There you go.
Okay, got it. Yeah, laser pointer. Great. Oh, good. So you can see my pointer as well, right?
Yeah, we can see that.
Okay. All right, so thank you. I'm going to talk about preparing a competitive NSF proposal, as Tracy mentioned. And we are going to talk about an introduction, some format, but this is only suggested. You can have your own format. There is no hard and fast rule. We are going to discuss the merit review criteria, the integration of research and education, especially for career proposal assessment, some tips, and one section about my own experience in career proposal about learning from the mistakes. So there's few rules that need to be followed, and I'm not going to go through all of them, but these are some of the essential things to remember. One very important thing is to read carefully the program solicitation and the announcement, because every announcement might have a little different or some specific requirements which you have to follow. You have to make sure that your goals and objectives are measurable. For example, you can say that, I'm going to enhance student learning. It's a lofty goal, but it's not measurable, right? So that's something NSF emphasizes, that you need to have things that are more like measurable. And of course, you have to make sure that you check your spelling and everything, because as you see in the spell check, complementary versus complementary are the same, principal versus principal are the same, so it's not going to be picked up. So more just doing the spell check is not enough. You have to just read it several times to make sure you're not doing any mistakes. Especially for the career proposal, one thing that's very important is the integration of research and education. And if you read the solicitation, you're going to see that it says like this: early career faculty should build a firm foundation for a lifetime of leadership in integrating research and education. So it's not about career proposals are not regular research proposals. It's something different, and it's much more involved, I would say. So there is no formula to write a proposal, and this is applicable for both regular proposals and career proposal. But generally, the way that I start with, I put like a 2-page of introduction, which is almost like a standalone executive summary. So the first 1.5 pages kind of overview and objectives, and then we talk about the expected significance. And based on many people I heard, especially like Dr. Joy Poshke from our NHERI program, she says like your research objective should be the sentence 1 of paragraph 1 of page 1 of your project description. You don't want to find that in page 7 or 8. You have to put it up front. What is your research objective? Also, be careful. Make sure that you are making a next vertical step in the research continuum, and make sure that it's something that you have systematically pursued and as it's reflected in your bias sketch. So these are important things to do. It's always good to put some preliminary studies in the background sections and discuss what are the research, not only in the literature that are published, but also current research going in other places by other investigators elsewhere. It may not be published yet, but you can find it by going to your NSF awards search and looking at what research they are doing, or maybe go to their websites, and then you have to make sure that you put those in your literature review section. Otherwise, I have seen cases where reviewers say, hey, you have missed that. It's done in Western Ontario or somewhere else, and you don't have any reference to that. One important thing that is to identify some potential problems and offer some alternative approaches, how to solve those potential problems. Okay, you don't want the reviewers to find out like there could be a problem and you haven't thought about it, right? So you have to be proactive. For career proposals, you have to add in your research plan also, or you have to also add your educational plan. So that means you have to make sure that you have the educational aims that addresses the needs, and have an assessment. And I'm going to talk about the assessment later on. Okay. So I'm going to just talk a little bit more about this overview and objective section, which I describe as the executive summary. It gives you the big idea of what is this proposal about, right? And it's going to act as a hook for the reviewers, okay? And you want to convert the persons or the reviewers who have to read your proposals to those who want to read your proposals, because they get so interested by reading your first 2 pages. And of course, you have to make sure that you highlight the importance of the issue or the problem that you are proposing to work on, okay? So that's kind of the big goal. There are many kind of proposals, hypothesis-driven, need-driven, or a hybrid. Generally, we go for the hypothesis-driven proposal. And here are a few examples. And again, this is very important for us to understand. What is an hypothesis? So in my career proposal, let's say the hypothesis was that a membrane deformation and fluttering on a flexible roofing system alter the separation bubble, the shear layers, and other flow structures, and alleviate the building-induced turbulence, which could lead to lower the peak pressure. So it's a very well-defined hypothesis, which can be tested, right? And you can find maybe your hypothesis is wrong or your hypothesis is right. So hypothesis is something that comes out of your previous studies and your experience and the literature, that, okay, this is the best bet to reach or to attain my objective. So what would be the research plan to test that hypothesis? In the aim 1, I might develop a computational model that relates these aerodynamic pressures with the system flexibility and the deformation. Then aim 2, I can have a series of testing in the wind tunnel where I can measure the pressures and the roof fluctuations. And in aim 3, I can use those, I can compare those the computational and experimental results to calibrate and validate my computational model. So with this, I can easily test my hypothesis and see if my hypothesis is right or wrong. And just to give you an example of the anticipated problems and potential solutions, I can say that, of course, this is a great plan, but synchronized measurement of these pressures and deflections using different sensors, which have different frequency response and different sampling rates, could be a challenge. And I say that I recognize that there could be a challenge, and I propose like a trigger mechanism or something that will help to synchronize the data. So this is kind of an example. So what is the progression of logic for a proposal, especially that's going to be covered in the first 2 pages in the executive summary? I first need to identify the knowledge gap. And as we know that National Science Foundation, NSF, the middle word is science. So you have to make sure that you are understanding a fundamental scientific issue, and there is a knowledge gap. And for career proposal, there is also an educational need for what you are trying to pursue. Then you're going to propose an objective, a scientific objective, and maybe an educational objective for career proposal based on that gap and the need. Then you're going to state the hypothesis. It could be a central hypothesis for your research and educational hypothesis for your education. And as I gave you example in the previous slide, that you have to put some specific aims or as we call tasks to test parts of that hypothesis, okay? Upon testing that, you're going to state these are my outcomes of the research, and it could be scientific and educational outcome for career. And these outcomes are going to go back, as you can see, to attain the objectives that came out right from the gap. And as the objectives are attained, it's going to go and plug the gap that you identify in the first place. So it's a very logical cycle or we call the linear progression of logic that sets up the tone for your proposal. So few things that are very important here, like the rationale. What will become possible after my research that is not possible now. That's an important thing. Am I well prepared? Do I have the physical and intellectual resources? How is my project special and unique? That talks of the creativity. And why this is original, okay? Will this significantly advance knowledge? Has this been done before? So, and for the expected significance, you have to state just not the outcomes, but what are the new products that are coming out of your research. And I'll give you some examples of those products. And you have to also state why this contribution is important and what are the credible list of benefits once these contributions are made, okay? So again, going back to my, I just gave you the hypothesis of my research. And how do I turn off the, let's see, okay. So if you look at this video, this is exactly the hypothesis I made, right? I said the deformations of a flexible roofing system are going to interact with the various flow features, and that might have a reduction effect on the pressures. So this was my hypothesis, and I tested out. So for my particular career proposals, if I just go through some of the samples that I kind of alluded before, what is the scientific outcome? The scientific outcome is the new knowledge of the dynamic behavior of flexible roofing. What is the contribution? Is a new product, which is a new computational methodology for assessing loads on flexible roofing. And what is the significance? It's going to provide us enough knowledge that we can enhance the resilience of currently vulnerable buildings. Okay, what about the education? The educational outcome is in the process, I'm going to integrate the education with the research with education, and I'm going to have a new group of hurricane qualified engineers. And the contribution is I'm coming up with a strategic framework for influencing the career path of these undergraduate students. And the significance is they are going to enhance the resilience of low-rise buildings because we are going to have a new set of well-qualified engineers, okay? So just talking about the merit review criteria, I address the advancement of knowledge, which is the intellectual merit. I also address the benefit to the society, which is kind of the broader impact. As you can see, I have touched on how this is creative and original. And I have a well-reasoned plan, and I'm well qualified, I have the resources. And finally, the one I put in red is I'm going to discuss later, but I didn't tell you much about the assessment of the success. And I'm going to talk about this topic later on, but it's kind of all the review criteria are kind of addressed. You have to make sure that the reviewers, they want to know these following 4 things. What is this about? The research objective, which has to be the number 1 line of your proposal. How are you going to do it? What is the technical approach? Do you have the expertise and the available facilities to do it? And is it worth doing? That means what is the intellectual merit and broader impact of this topic? So now I'm going to just talk a little bit about the career proposal, which has, in addition to these things, that you have to highlight the firm foundation for a lifetime of contributions to research, education, and their integration. And if you read the NSF solicitation, you're going to see that there is no specified approach, but they want you to think about creativity in terms of reciprocal relationship between research and education. That means they are informing each other. This is where maximum of the career proposals don't get successful because the integration is not very solid. Okay, so as engineers or researchers, we have to make sure that the integration is very solid, and I'm going to talk more about that. And another thing you're going to read in the solicitation, that they're going to say that it reflects the proposer's own disciplinary and educational interest and goals, and it also needs to be in the context of his or her organization. So it's very important to look at your organization, your university, and see like what kind of goals they have. So how do we integrate research and education? The best way, I think, to integrate research and education is to learn about what are the current status of integration of education and research. And there are some excellent journals and I highlighted some of these: Journals of Engineering Education, Advances in Engineering Education, IEEE, and this is an example. So the best thing that you can do if you're especially submitting a career proposal, and also now there is a requirement for even unsolicited proposal to have a section on education, I think it's best for you to go and study some of these papers. So as we do a literature review of our research papers, you should also do a literature review of our educational papers and see the state of the art and what is the educational need. So by reading the research papers, you know the research gap. By reading the educational papers, you know the educational need which exists right now. Okay. So I'll give an example of my career proposal. So when I read all these 60 plus papers on education, I found that there's an urgent need that National Science Board mentioned about how we need to develop more hurricane qualified professionals, and many others also emphasize the same need. And then I saw that the major hindrance to fulfill that need is sustaining the undergrad students, because half of them, they leave after the first year. So there is a problem with retention. And I also saw that inductive learning, which is a new way of teaching, is something that can enhance the self-efficacy and motivation, and it can create or increase the number of undergraduates in programs like hurricane engineering. So when I put that as an objective, increase in the number of undergrads, it's become measurable. See, that's what I mentioned earlier. You have to come up with objectives that are measurable, not something that's abstract, right? So this objective is very measurable. And I also had an hypothesis for education. I said that inductive learning can improve the self-efficacy and persistence, and it can lead to retention of undergrads in these kind of natural hazards engineering program. And then if I can give you some examples of the aims, I said that I'm going to integrate the low-rise building research, which I showed you the video of the aerodynamics of flexible roofing, with inductive learning, so I can improve the undergrad student retention. And how am I going to do that? I'm going to provide problem-based learning with open-ended questions, and inductive learning that's going to use the research results from the Wall of Wind lab and ask those students some open-ended complex questions, so they are aware of the research that's ongoing. So I can create this integration between the two. And then I will also evaluate and disseminate to amplify the facts. And the expected outcome will be an increased pool of diverse students who will become hurricane qualified engineers to address that need that I got from the literature review. So in my case, it was good, because Miami is, as you know, is always as a sitting duck for these hurricanes. So I know that from some of the research, it says like lifelong learners, to become lifelong learners, students need to use the science to grapple with the problems that they care about. So we had so many hurricanes in our region, so the students are really familiar with, they know this as a practical problem in their life, so they will be more caring to solve this problem, and it acts as a powerful motivator. And I can not only engage engineering and science students, but also non-science majors who can come and learn about this problem and try to solve this problem. And I told about how to connect this to the organization context. And I went and found that in FIU, they have already used these kind of active learning or team-based learning or inductive learning, as we call it. And they had huge success using project-based learning to get nearly 100% retention of student in the physics course or in the physics program. So I said, well, this is already a mission of my university. So yes, my career proposal is already in context of my organization. Okay, so my university can support me. So the way that I did it, this is an example of the inductive learning. So I had classes where students are in groups, and I support them, but I don't teach them directly. And there are learning assistants who are also undergrads who are helping their peers with the open-ended questions that were asked. okay? And they become themselves informed or educated in this process. And this is an example of one of our student, Dr. Manuel Matus, who was a learning assistant, and now he's a PhD student under Dr. Ioannis Zisis. So it impacts students' life as they interact in these kind of programs. And we also hire them to work at the Wall of Wind. So here you're seeing on the right-hand picture how some of those students from this class now come to the Wall of Wind lab to do hands-on experience, so we can integrate the research and the education. I talked about assessment, and this is another important topic. You can always go to this assessment guidelines at NSF. There is available online. And I hired one of our faculty from the Global Learning Group, Dr. Hilary Landorf. She did formative evaluation throughout the life of the project, in which we are trying to gauge our students being retained in the hurricane engineering program, because that's a measurable goal, objective. And at the end of the project, we also do a summative evaluation to see what is the status of the fully implemented project, okay? So the assessment part is very important. Some more tips. I told you about preliminary studies. So this is the preliminary study. Remember, I said my hypothesis was that flexible roofing based on the deformations should be able to reduce some of the wind loading and the peak pressures. And here is some data we got from the field, which shows that the flexible roofing, which are the red lines on the top, pressures measured and compared with the rigid roofing, and you're going to see that, yes, there are some attenuation of the loads based on the comparison. So this are some preliminary data that puts more confidence in the hypothesis that I made. Other than that, I talked about the potential problems and alternative approaches. It's also applicable to education. For example, when I read the literature, I saw that many students, they become hostile and resistant to inductive learning because they have to do a lot of work by their own and not spoon-fed by the professors. So there could be some resistance and hostility. So I said that doing the formative evaluation, I'm going to come up with some methods of knowing what these potential problems are. Then I'm going to implement something called scaffolding, where I give some support in the beginning. And as the student become more familiar with this inductive learning by learning with their peers and their teams, I'm going to slowly remove the scaffolding. And that's what exactly I saw in my class. I mean, in the first 1 or 2 weeks, they were like lost, like, why should we do all of these activities on our own? But then at the end, at the middle of the class, they becomes very happy that they're learning, okay? So a few more tips. I think any proposal, you should have it reviewed by a trusted group of people, like 5 or 6 faculty from various disciplines, so they can give you some feedback. When you write these proposals, especially career, do not speak only to the specialist, because a lot of other people may be reviewing it. So try to come up with, try to avoid the jargons and come up with a more straightforward approach, which is easily understandable. And try to get yourself on a review panel if you can, by requesting your program director and serving on some of these review panels, so you know how the dynamics of these reviews work. So having said that, the last topic I'm going to present is learning from my mistakes. So one thing that in my first submission happened is I put too much. And the comment I got is, like, they said, any one of these tasks is an entire career proposal by itself. Okay, so you have to make sure that you're not proposing a whole lot. So they said, like, you know, review the long list of goals and select 1 or at the most 2. And for the integration, they said, like, these all look, the educational things look all like bolt-ons. There is not very much integration. And my recommendation, panel recommendation, was fair, good, and good. So it was not very good. In the second term, I changed some of the things. And then they said that, again, too many topics. We already have a successful outreach program, so nothing is kind of novel for the integration. And there's not also much novel contribution. So this time I got very serious and I looked at all those tips that I shared with you before, and I took a stab at it. Also, I worked on a consultant. I made my proposal reviewed by many other external people and internal people. And after that, when I resubmitted the proposal for the last time, it got funded. They said that it really addresses the fundamental knowledge, which is better wind estimates of pressures on flexible roofing system. It's a well-written and comprehensive proposal. The preliminary work shows that the chances of success is high. I have some unique lab facilities like the wall of wind. For the education, I'm going to establish a new hurricane engineering program, which is the first established program in the US for hurricane engineering. So all the educational and research things are very well integrated. And above all, I have the assessment of the progress, which is also very good. So that time I got 3 excellent and 1 very good, and I got funded. So it's very important to highlight these important things in your proposal. And I'm going to just give you 3 examples and show you how these things are very important. So this is an example of a career proposal that got funded with Professor Victor Maldonado. He's in TTU now. If you see that the new knowledge that he is developing is the characteristics of secondary vortices of the flow. And look at his hypothesis, which is so strong. He says that it is hypothesized that producing secondary vortices at the current length and time scale can lead up to the breakdown of blade tip vortices, which can increase the performance of wind turbines or airplane helicopter props or gas turbines, all the rotor-based flows. So this hypothesis is a great thing on his based on his preliminary results and can be very well tested. Another example by Alice Alipur from Iowa State, looking at aging effects on infrastructure. And the integration was very strong with the research and education because she proposed a multi-tiered mentoring program with bringing underrepresented minority students and also focusing on university industry partnership for the implementation of the findings. And last but not the least, another career proposal by Catherine Gourlay, and the advancement is in CFD modeling on urban flow and wind loading. And the broader impact is resilient and breathable cities and energy optimization around the world. So this is a proposal in which the intellectual merit and the broader impact were strongly suggested. And with that, you also need to make sure that you have the teamwork. You cannot get a co-PI, but you still can get letter of collaborations on a career proposal and get letters from the industry or other collaborator, because as we believe that none of us are as strong as all of us, so teamwork is important. With that, I'll be happy to get any questions. Thank you.
Thank you very much, Arindam. Very informative talk.